Hello everyone, welcome to VLSI Academy. This is Physical Design course, lecture 12, part 6 on Physical Design Inputs Technology file, where we shall be looking at some very important and interesting topics for those who are in academics and in engineering world. Alright, in previous lecture we have briefly discussed about netlist, lefts, timing, libs and constraints which are needed as an input to the physical design team, what netlist lefts and timing libs contains and how to understand it, that we have already discussed in the previous lecture, link of which is given in the description below. Today we will understand about another input, that is technology file, and we will understand why it is needed, what are the contents of it and why it is important. Here we have taken the example from the tech file of an RF chip. You might not find exact same technology file in your project, but this should be sufficient for understanding. The first two lines here, it defines the chip X and chip Y dimensions. For best results, here we have given the area of FFT, which is about 4 times the area of the layout. FFT size determines the accuracy of your simulation. It is generally mentioned in chip designs related to RF chips. In addition to all of this, we have here tech file, which is the name of the file, and tech path, which is the file path of the parameter of the your technology file. Then there is frequency, which we have to mention here, frequency of operation, and then we have AD layer related information here. There are more process specific parameters that are mentioned in the file, such as sheet resistance, sheet thickness of various layers. These technology files describe the generic CMOS and BiCMOS processes. Here we have taken the diagram of CMOS to explain the better about the contents of technology file. So this is a layer-wise information. Here the layer statement defines the various dielectric and substrate layers. A conducting substrate layer is specified by stating its resistivity. So you will see rho here, which is resistivity in ohm centimeter, and then a dielectric layer can be modeled as an equivalent resistivity according to the dielectric loss tangent. So you will see here permittivity and thickness also. The thickness is specified in microns. The relativity is actually, this is unitless. So you have to notice that substrate layers are defined from bottom to up. It is like we have substrate here first, so substrate layers are mentioned first, and then comes the higher layers. These are the important technology specific information only which we have specified, but in reality the tag file is much larger and contains a lot of information depending on which technology you are checking at. The most common information remains in all tech node is the metal and VR related information. So you can see here all the metal layer information, such as this is, let's say, metal 0. So the layer name is 1 here, its sheet resistance, its thickness, and its name, its color. These are the common information which remains in all technologies. And it will, here we have only shown metal 0 and metal 1, but there will be so many other layers which can go up to metal 13 also, and that all depends on the technology, but the context remains the similar only. That's all for this video. In next video we shall be learning about what def file is, what it contains and why it is important. Please like, share and subscribe to the channel. Thank you.